All right, today we're going to learn how to do something that sounds, well, pretty much impossible. Weigh an object that's floating without ever touching a scale. Okay, so let's dive right in. Picture this. You've got an orange and you need to know how much it weighs, but your kitchen scale's batteries are dead. You're stuck, right? What do? Well, it turns out you're not stuck at all. Now, this might feel a little bit like a magic trick, but I promise you, it's not. All you need are a few things you've definitely got in your kitchen and just a little pinch of science. It's actually a super fun experiment you can try the second this is over. So, here's our super simple toolkit. Go grab a measuring jug, an orange, an apple or a lemon would work too, basically anything that floats, some regular tap water, and a pen and paper to jot down a couple of numbers. Seriously, you probably have all this stuff within arm's reach. Okay, let's get to the experiment itself and see how this whole clever process works. It's time to get our hands wet, maybe literally. The procedure here is incredibly simple. Step 1, pour some water in the jug and just write down that starting number. Step 2, gently place the orange into the water. Step 3, take a look at the new water level. It's going to be higher, of course, and write that down. And finally, step 4, just calculate the difference. That's it. 4 simple steps are all that separate you from the answer. Okay, so let's use some real numbers here. Imagine you've placed the orange in the water. It bobs around a little and then settles. You look at the measurement on the side of the jug, and let's say the new water level is right at 750 milliliters. And remember, before we put the orange in, our starting volume was exactly 500 milliliters. So the trick here is finding the difference between those two numbers. And that difference isn't just a random number. It's the exact volume of water that the orange had to push out of the way to make room for itself. We've got a great word for that: displacement. And the math could not be easier, right? 750 milliliters minus our starting 500 milliliters leaves us with a difference of 250 milliliters. Okay, hold on. We have a volume, 250 milliliters, but we wanted a weight, remember? So how on earth does a measurement of volume magically turn into a measurement of weight in grams? Well, this is where the really clever part comes in. Here is the secret sauce that makes it all work. Thanks to the beautiful simplicity of the metric system, 1 milliliter of plain old water has a mass of exactly 1 gram. It is a perfect, clean, one-to-one relationship. So what does that mean? It means that the 250 milliliters of water our orange pushed aside weighs, you guessed it, exactly 250 grams. And because of the laws of physics, that has to be the weight of our orange. How cool is that? Now, this isn't some weird fluke or a lucky coincidence. It's a fundamental principle of physics, one that was figured out over 2,000 years ago by the brilliant Greek mathematician Archimedes. So let's pull back the curtain on the magic and see exactly why this works every single time. So the first big idea you need to get is displacement, and it's really simple. When the orange goes into the jug, it has to physically move water out of the way to make space for itself. It is literally taking the water's place. Now, as that water gets pushed aside, it doesn't just give up, it pushes back. It exerts an upward force, and we call that force upthrust. This is the force that's constantly fighting against gravity, and it's the reason anything can float in the first place. And here's where it all clicks together. An object, like our orange, will sink into the water just enough until that upward push from the water, that upthrust, is exactly equal to the downward pull of its own weight. It's a perfect balancing act. So let's see how this all comes together into one beautiful, simple rule. This is the golden rule. The one takeaway that explains everything from our little orange to a gigantic cruise ship. So, here's the bottom line. For any object that floats, the weight of the water it displaces is exactly equal to the weight of the object itself. That's it. That's the whole secret in a single sentence. And there you have it. What seems like a really clever parlor trick is actually just a fantastic, hands-on demonstration of a core law of science. It's elegant, it's simple, and it just works. It's not magic, it's science. So now that you know the secret, what else can you find floating around that you could weigh? A lemon? An apple? Maybe a little plastic toy? The principle is always the same. What can you discover in your own kitchen?